My name is Alex Niedra. I'm the business manager of PKI Distribution. It's part of the Toromont team. That's our Perkins distributorship. Joined here today by a few of our colleagues here in the industrial engine space, and really, quite frankly, very excited to be sharing with you today a topic that I know is likely close to many of us, which is the engine emissions. In industrial space, this is a place that we're seeing a lot of evolution, a lot of change over the last number of decades, last number of years, and a number of changes that we might be seeing in the coming years ahead. And so without further ado, I want to introduce you to the team that's going to be presenting to you today. We have joining us today a number of experts across the spectrum in the industrial space. I'm just going to jump over to the next slide here. We're joined by our three panelists. So I will be moderating today, presenting a few topics and questions to the panel. I primarily have been in the industrial space here for the last 4 years with the Toromont team, 7.5 years in the industry. My history had my beginnings with a remanufacturing group, serving the mining and construction spaces, and then later on joining our industrial engines team through PKI Distribution. Joined today by Daniel Tran, Tsenos, and Jim Hepburn. I will let these three gentlemen make a quick introduction. Dan?
Good afternoon, everybody. My name is Daniel Tran, and I'm part of the PKI distribution group here as one of the account managers. I've been in the role for the better part of a decade, and excited to be here with everybody today to talk through a topic that's of interest to everybody.
Thank you very much.
Good afternoon, everyone. My name is Tsenos. I am the industrial account manager at Toromont Cat and representing the Cat brand. My territory covers northeastern Ontario for industrial engines. Been with Toromont for about 29 years now. Been in this role for just a little over 10 or maybe 12. In my previous role, I was in parts and service marketing over on the tractor side. So I'm happy to be here with you today and talk to you a little bit more about emissions. Thank you.
All right.
Yes, and hi everybody, my name's Jim. Like Sam, I also come from the tractor side, but right now I handle product support for the Perkins engine in Ontario and all of Manitoba also.
So thank you very much. A few quick administrative notes before we begin the presentations. First, just wanted to make sure everyone was aware that this meeting is being recorded. So if you do not wish to be recorded in this webinar, you may leave the session at any time. And then additionally, I want to quickly make sure that everyone was aware the presentation information within the presentation are provided without a prejudice basis. And in no way does it constitute or nor should be construed to constitute any sort of legal advice, guarantee, offer, representation, or warranty on behalf of us or Toromont. And so we will be offering suggestions on the part of myself and the panelists as to several possible customer scenarios, just to make sure that everyone's aware the answers given by the panel members should be used as a guide. Okay. We'd like to start off our meetings and our presentations with a safety talk, and we thought that it would be beneficial to talk a little bit about safety of the roadside. Obviously, in most parts of the country now, we're exiting winter, we all hope, and we're entering a time when we'll still be spending a lot of time on the roads. We hope that everyone will have an opportunity over the spring and summer to get on the road for a road trip away with family and friends. And so safety at the roadside is something that is very near and dear to some of us, and really important to make sure that we're taking the right steps to keep those at the side of the road safe, and as well to make sure that we're keeping ourselves and our loved ones safe if ever we find ourselves in an emergency or situation at the roadside. So we put together a few points we want to share with the group here today. First and foremost, the importance of slowing down and moving over. It's the law for emergency vehicles, including those with amber lights. That's the law in Ontario and Quebec. Really just want to highlight the importance of doing so, right? So if you see an emergency vehicle, again, it could be paramedic, police, fire, but also any emergency vehicle with amber lights flashing to move over, give one extra lane of space for that vehicle and for those individuals. If it's not safe to do so, if it's absolutely not able to do that, to slow down and make sure we pass safely. Secondly, pulling over in a safe place. So if it's not safe to move to wherever you might be stopped, if you pull over into a safe location, right? If you're in a dangerous situation, let's just say you have car trouble and you're in a live lane or you have cars passing at high speed, make sure you contact the police, call 911 because MTO in Ontario and other services provincially across Eastern Canada are able to come and assist. And they'll get some flashing lights behind you to keep you and your family safe if you're in that sort of situation. Stay in your vehicle unless you absolutely have to exit. And as well, very important, they happen, collisions. You know, if you're involved in a collision, they can be a very troubling situation, a lot of things changing at the same time. Make sure to pause, slow down, assess the next steps very, very carefully, and at all costs, avoid walking on the roadway, right? You might see the signs here in Ontario, steer it, clear it, right? To get our vehicles to the roadside. That's the safe place to be. That's where help can come and make sure everyone's safe following that sort of situation. And the last one here, we might think applies only to winter, but I would say it applies year round, being prepared, right? Just to consider the unexpected. Extra washer fluid, you know, warm clothing, a blanket for the wintertime, just in the case that you find yourself the roadside with some trouble for an extended period of time until help arrives, okay? So without further ado, we'll get right into our first question here. And pardon me, the first thing as well to mention that for any questions you might have over the course of the presentation, you might email those directly to Sharon Jake. He's joined us here on the line, so he's accepting those via email over the course of the presentation. So if you do have a question, we're going to keep his email in the footer of the slides. Feel free to send those over and we'll be reviewing those in the Q&A period following the panelist discussion. And we will also at that time be opening the Q&A chat. So please hold your question. If you'd like to put in the chat, you may do so at the end of the presentations. Okay. So Daniel will be addressing our first topic. And the question here on the slide is, what is the current off-road compression ignition emission standard in Canada? Dan?
Thanks a lot, Alex. Daniel here again. And if you wouldn't mind just the next slide over here. So I figured I'd start by explaining what do we mean by emissions in Canada. It can mean different things depending on the industry, but it's specifically when it comes to compression off-road ignition engines, we're only talking about two things in regards to emissions. The first of which is nitrogen oxides and particulate matter. And these are the only two things that Environment Canada is focused on when we're talking about emissions specifically for compression off-road diesel ignition engines. So our journey with emissions in Canada really started about 30 years ago in the late 90s, and that started with Tier 1 emissions. Tier 1 emissions is represented by the gray box in this chart here. And slowly over this course of this 30-year journey, in the early 2000s, we started to move to Tier 2 emissions, which is kind of that dark orange. And then later in the 2000s, we moved to Tier 3, which is the blue box as well. And then finally, when we get to 2013, that is when we moved to Tier 4 final emissions. So that's in 2013. And what this represents is roughly a 96% reduction in emissions for engines greater than 174 horsepower in particulate matter and nitrogen oxides. So you kind of see it's represented in this graph. That gray section was Tier 1 emissions, and that tiny little light blue box you see in the left-hand corner represents where we are today with Tier 4 final emissions. Next slide, please, Alex. So Environment Canada focuses on two applications in regards to emissions for compression ignition engines. The first category is mobile applications, and Environment Canada considers mobile applications to be any sort of application that is on wheels or is intended to be moved. And so it could be on a skid base, but intended to be moved back and forth. They still consider that to be a mobile application. So regardless of the power range, whether it's below 37 kilowatts or greater than 37 kilowatts, the current emission standard for mobile compression ignition engines is Tier 4 final across the board. So all these engines would need to adhere to Tier 4 final emissions. Next slide, please, Alex. The second application that Environment Canada regulates is stationary compression ignition engines. So stationary is defined to be a fixed installation set there, intended to live its life there, and not necessarily intended to be moved and is not on wheels. Stationary compression ignition engines are further separated into two categories. The first category of stationary compression ignition engines is non-backup and non-remote applications. And similar to mobile applications, regardless of the power node, if it is a stationary compression ignition engine for non-backup and non-remote applications, Tier 4 final is the current emission standards for those applications. Now, the second subcategory within stationary compression ignition engines is backup, emergency, or remote applications. And Environment Canada defines remote applications to be any sort of application that has no access to utilities, so something like grid power or natural gas. So stationary, backup, emergency, or remote engines, depending on the power node, can adhere to regulation emission standards lesser than Tier 4 final. Specifically, 37 kilowatt and below can be Tier 2 emissions. 37 kilowatt to 560 could adhere to Tier 3. And then finally, greater than 560 kilowatts must adhere to Tier 2. Next slide, please, Alex.
And then the second question here, how are engines labeled from an emissions point of view?
So we thought that this would be an interesting thing to address here, simply because you can have a Tier 3 engine, and the difference between one being compliant and not compliant is strictly just the labeling. So you could have a Tier 3 non-compliant engine, and you could have a Tier 3 compliant engine. Because Tier 4 final is the current emission standard, they're all considered to be compliant. So next slide, please, Alex. So I figured we'd attach some examples to help everybody and the audience here determine, okay, how do I know if my engine is compliant? So the first example to the left here is an example of a compliant engine. This is one of our Tier 4 final engines, and it states this engine complies with US EPA non-road and stationary regulations and California off-road regulations. So this is an example of a Tier 4 final engine, and it is compliant across the board, regardless of whether it's used for stationary or off-road applications. An example on the right here would be an example of a stationary emergency use engine only. And again, it explicitly states that it complies to EPA regulations for stationary compression ignition engines. And I know it's a little bit hard to see at the bottom there, but it specifically states for stationary use only. So this would be an example of a Tier 3 engine for stationary emergency use only. Next slide, please, Alex. Mm-hmm. This third example here is one of a replacement engine. So Environment Canada does also regulate replacement engines, which is something my colleague Jim will go a little bit further in detail with in his slides. But replacement engines are also appropriate labeled by Environment Canada standards. And again, it explicitly states that it is a replacement engine only. And so because a replacement engine can match the tier of the engine it's replacing, that's where it's specifically labeled to denote that although it is a lesser tier, it is purely a replacement engine. So An example on the right-hand side is one of a non-compliant engine. This is a Tier 3 engine, but non-compliant. And as you can see, it explicitly states that this engine is solely for export out of the US and out of Canada. We do see uncompliant engines in our territory, and this is something that would help the audience here determine, do I have a compliant engine or not, and does it comply with Environment Canada regulations. So just going back to that first point here, you can have a Tier 3 engine that's compliant based on the labeling, or you could have a Tier 3 engine in territory that's not compliant purely by the label. And that was it for labeling on engines. And my colleague here, Sam, will go through some of the technology involved in how Caterpillar and Perkins make their Tier 4 final engines. Thank you.
Thank you very much, Dan. And next up, like you did mention, Dan, we're going to be moving on to our next question, taken care of by Sam. The question is about some of the emissions technologies used on industrial engines currently. Sam?
Thank you, Alex. Okay, so when we look at Caterpillar lines of engines that they have in the marketplace today, it's quite a wide range, anywhere from a C0.5 or a half-liter engine, 7.5 horsepower, all the way up to a 3600 series, over 6,000 horsepower engine. So there's lots of different technology there in relation to emissions and different strategies on dealing with that. The smaller engines, C0.5, 0.7, 1.1, anything less than 19 kilowatt is what's also referred to NTE engines, or the term not to exceed, right? Those are smaller engines. Not much has changed in those. Those were relatively clean in Tier 2 and Tier 3. Some models, and depending on the manufacturer, might have something as simple as an altitude derate, depending on where the altitude is, so it complies with emissions. There might be a small electronic in the governor to control that. But aside from that, there isn't anything drastically different for Tier 4 final with the smaller half-liter to 1.1. When we start getting into 19 kilowatt and above, all the way up to 74 horsepower, you'll see mostly DOCs, right? Diesel oxidation catalyst, and also Caterpillar earlier on with going through Tier 4 interim and Tier 4 final, knowing that Stage 5 was just around the corner for Europe, and being that Caterpillar is a global company, they went all in and decided to use DPFs on Tier 4 final engines as well. So on the all the way up to 74 horsepower, you'll note there is a DPF on those engines. Now 2.8 to 2.8, 3.6, all the way up to C15, C18. You'll notice I have that area circled around there. That is the area there that's anywhere between 75 horsepower and above, all the way to 755 horsepower. And that uses diesel oxidation catalyst, which we will talk about a little bit more in detail, and SCR and DEF fluid as well. You'll notice the 2.8, 3.6 is actually outlined right in half. I actually purposely did that because that's an interesting engine and power node. So all the way up to 74 horsepower, no need for DEF, right? So you can get that engine all the way to 74.9 horsepower, so to speak, without the use of DEF. And then when you go over 75 and above that, which the 3.6 is, you can get that all the way to 134 horsepower. Then you have the introduction of an SCR system, with the use of DEF. Next slide, please. So I am going to apologize ahead of time. Lots of acronyms, right? You'll hear terms like NRS, DOC, DPF, and different strategies from all the way from 75 horsepower all the way to 750 horsepower. We'll talk a little bit about passive, went backward. Go one over. Passive with active regen, or regen not required. Passive with back pressure valve. The term okay to elevate, where the engine will actually do its own process of just elevating the RPM to meet that heat, and so on. Next slide, please. So as far as technology is concerned, it really is building blocks, lots of different components that make up the complete system. Starting off with the fuel system, on the smaller engines, Caterpillar is still using a common rail fuel system, very common, very reliable. On the larger, we use the mechanical electronic unit injection, still very popular in anything C9 C13 and above that. Next generation turbochargers, lots of advancement there for Tier 4 final and Stage 5. Different manufacturers use variable displacement or variable geometry turbochargers. Caterpillar tends to stay away from that and like to use two-stage turbos instead, just a little bit more simpler. Tend to get a little bit longer life out of them. So you have a low pressure turbocharger and a high pressure turbocharger in systems that can give you some flexibility and lots of power and torque throughout the whole RPM range. NOx reduction system, NRS system, again, we'll just talk a little bit more into that. And like I said, acronyms, lots of different acronyms in the different after treatment technologies. Diesel oxidation catalyst, diesel particulate filter, SCR, selective catalyst reduction, and with DEF injection and so on. And we'll talk a little bit about that system, and the whole regeneration system and passive with back pressure valve and the whole CRS process on that. Moving along from the generation, the DPF regeneration system, PETU, that typically in the industry is one modular unit. Most manufacturers have gone with one self-contained unit, and that really becomes your tank where your DEF is stored. It also is where the pump lives, a lot of the electronics for the pump, and the heating unit for that. And it's all kind of in one unit. And along with that, you have the lines that will go into the engine, and they're offered in different sizes that helps move that from the tank into the actual after treatment. And at the end of that operation, everything gets returned back to the tank. And those lines are actually heated that go back to the PTU because DEF does freeze. And so at the end of the operation, that fluid gets back sent into the tank so it doesn't freeze and the lines are freeze in the after treatment. And of course, you can have all this lovely technology, but you need the brains of the operation, so to speak. So next generation electronics and control software. There is a separate CEM that looks after, or ECM, I should say, that looks after all that after treatment technology. And there's been a fair bit of involvement in that with some of the newer 9.3B and C13B engines as well, where Caterpillar has simplified a lot of the wiring and a lot of those sensors go into one computer, where before it was going into multiple units. So it really is a whole systems approach and a building block kind of that puts it all into one little package. Next slide, please. So along with that, as an example, I'm just using a 9.3B here. One of the things we have seen in the industry is increased performance. A lot more power, a lot more torque. So what's happened is you could almost go from tier 3 to tier 4 final. You could almost go down an entire engine size in some cases. So just to give you an example, 4.4 liter used to be a mechanical engine that used to be 80 horsepower and 91 all the way up to 127. Now for tier 4 final and stage 5, that 4.4 liter engine is you can get that at 130, 139, 148 is one power mode, 174, and all the way up to over 200 horsepower, which is almost reaching at C7, or you are at C7 size engine. The C7 was before 225, 250. Now we're seeing them go up to 350, which is in 9 liter kind of territory. So lighter engine, the after treatments have gotten tighter, lighter, a lot more flexible. Lots of different options for OEM when it comes to integration on that after treatment system. Not all OEMs can use kind of your top mounted after treatment like you see in the illustration there. That is ideally, if you can ideally use that setup, that's great, because that's what it's been pre-certified by Caterpillar, and there's a lot of the engineering and the auditing is already done on kind of a complete system approach. But if not, we have lots of OEMs that choose to go with remote mounted or different orientation and so on. So there's lots of different options there. And we've noticed the difference in operating costs, right? Fuel consumption or mixed fluid consumption. That's one of the things you'll notice in the industry when we talk about fuel consumption, because DEF's not free, right? There is a cost to DEF. So different manufacturers use different systems. And of course, with a different system, you could have more DEF. The use of more DEF will ultimately mean that your cost to operate that piece of equipment, when you combine the fuel and the cost of DEF, goes up, right? So that's one thing you always got to look at, is not just fuel consumption, but complete fluid consumption for an engine. And there's lots and lots of hours on these engines. This is not something new. So there's been lots of engines in the field, out in the field, whether it's highway or off highway, lots of hours in field testing. Next slide, please. So when we look at kind of a lot of these parts, to my point from the previous slide, this technology has been around for some time, right? So when we look at turbochargers, and that technology has been around since the 50s, air-to-air after cooling, 1985. That after treatment technology really started in the 90s, and we saw it in the truck world, right? A highway truck first. So I know 2004 was a big year where that assert technology and DEF, and there was lots of chatter in the industry about, DEF tank next to your diesel tank, and now there's another fluid and so on. And so it has been around for a very, very long time, and millions of, miles and hours of field testing. Cat clean emission modules, diesel oxidation catalyst, and DPF's been around for 2011, so that's it's 15 years now, and the SCR since 2014, so over a decade as well for that development, and constantly improving, right? So at any chance that Caterpillar has to improve that piece, that technology, they do so. Next slide, please. So when we look at, I'm just going to take you through. So when we look at an after treatment assembly or module, I should say, here is kind of a cutout of a top-mounted after treatment assembly that includes the DOC. So your exhaust will go through the DOC, and a DOC is a catalyst, or sorry, a diesel oxidation catalyst, which is similar to your catalytic converter in your car. That will remove your carbon monoxide and hydrocarbons, right? So that's the first. And after that, the exhaust will flow through the diesel particulate filter. That diesel particulate filter, that's what captures the soot and the ash, right? So that will remove that, and as the exhaust leaves through there, goes into the SCR catalyst. This is your selective catalyst reduction. That's where kind of the magic happens. And there is a mixing tube there where that's where the DEF is being introduced. And if we can go to the next slide, Alex. So when we talk about the CAT regeneration system or active regeneration system, I'll just walk you through some of the larger engines. We want to, and that exhaust goes through the mixing tube. In that mixing tube, we have a fuel nozzle that'll actually introduce fuel, and you will actually have a spark, right? So there is a spark plug. Yes, there is a spark plug in a diesel engine used in the after treatment, and we'll heat that brick up to 650 degrees Celsius. So that's over 1200 degrees Fahrenheit, and that's where that process will take place to convert your NOx, right? So your NOx will be converted to H2O and CO2 before it actually goes to the DPF, and then ultimately go through your tailpipe. Next slide, please.
Thank you very much, Sam. Now we're going to move over more to the operational side. Jim Hepburn is going to be discussing a little bit around how you can maximize uptime and look after your engine's after treatment system. Jim?
Yeah, thanks, Alex. On the product support side, yeah, this definitely lands squarely in my camp. So for this question, I wanted to highlight a couple of the basics, but also go beyond them a bit with some real life examples from our customers. So of course, the first thing that everybody should do in general to maximize the life of their engine is to read and follow the preventative maintenance schedule in their operations and maintenance manual there. And you should absolutely do, all the inspections, all the filter changes, all the DPF cleans, and you should do them on time. And though people might not want to hear this, it might be a little controversial, I don't know. You should absolutely use OEM filters. And I know they're more expensive for sure, but it's for reasons beyond the fact that they have the OEM stapled on the side of the filter. And so that's another acronym, I guess, Sam. So OEM, in this case, I mean original engine manufacturer. So it's because they're designed and they're engineered differently. So they fail less often, they let in less particulates, and so they matter for sure. But we can go beyond that too to some other stuff. So next slide, please, Alex. Mm-hmm. So first is to let it run. So this one comes right from our rental customers. Let the telehandler, the skid steer, the forklift, let it run. Don't shut it off every few minutes. We always hear that people usually do that, trying to save fuel. And, that's not inherently wrong. Of course, everybody likes to save fuel. I like to save fuel. But when you're shutting off a Tier 4 final machine every few minutes, you're not letting it get up to proper temperature. And if it's not going to get up to proper temperature, it can't do a proper regeneration of the after treatment system. And so when it can't do that, then you're going to get a lot of that accumulation of soot inside it. And that's when you'll start getting all those dreaded, warning lights for soot accumulation or other things like that we'd all like to avoid. And also, never shut off, and this is another basic thing, of course, too, but never shut off the engine in the middle of a regeneration. The rental customers that we have, they always say the number one thing that happens is when they have guys that take up the equipment and they let the machine run and they let it run all day, they never have any after treatment problems, or very, very few, compared to the guys that are always shutting it off intermittently. And part of that's because you don't want to shut that off in the middle of a regen. You'll get a lot of the same problems. So next slide, please, Alex. So secondly, I did want to point out the connection between your DPF and then the engine oil, which might not be super obvious. So Sam actually touched on this a little bit too in his presentation. He mentioned the importance of all the fluids that go in your engine. So as the engine oil burns, it produces two things. It produces soot and then also ash. And, soot we just touched on. So it's okay. So it's supposed to accumulate and then burn off, proper regeneration. But then there's ash, and ash is bad. Ash is a lot of unburnt metals like phosphorus, sulfur, and iron oxides, and that sort of thing. And it doesn't burn off, it just sits there. And if you accumulate a lot of ash in your DPF, it's going to start taking up a lot of the surface area inside of that DPF. And then the DPF has to work a lot harder to do the same thing it was doing before. It has to, not only does it get, hotter in there, hotter than intended, but it has to regen more. And then, not only does that wear the parts out, but it increases the likelihood that somebody's going to turn off that machine in the middle of a regen. And the reason why that's related to the oil is because you can actually get you can get oils that produce less ash than other oils. So I probably should have included a slide about this, so I apologize. But those oils are called low SAPS oils. So low SAPS, and that stands for low sulfonated ash, phosphorus, and sulfur. And those are oils you can Google. You can find them online or with a provider. Your dealer probably has some too, potentially. But that's a really important point there that a lot of people don't know about. And then thirdly is just, again, kind of going back to the basics a little bit, but it's just making sure that your DEF fluid is clean and uncontaminated. And that'll go a long way also towards making sure your after treatment system gets the proper life that it deserves. Next slide, please, Alex. I think that answers the question pretty good.
Excellent. Yeah, and the fifth question here, also addressed by Jim, is around replacement of engines. So what is required by Environment Canada to replace an existing diesel engine?
Yeah, well, Alex, mostly they want historical data on the old engine and then a declaration of intent most times. So it's important to note, though, right now, when it comes to off-road engines and when it comes to replacements and the current regulations from Environment Canada, that Tier 4 final engines are totally fine. You can they can be imported freely, is what I mean. So you can have a Tier 4 final engine going in anywhere in the country, in any application, with any kind of power rating, and Environment Canada doesn't need anything from you. You can bring it in freely, no problem. It is different though when you're looking to bring in a lower tiered engine to replace another. So this is when you're bringing in maybe a Tier 2 to replace a Tier 1, or maybe a Tier 3 to replace an older Tier 3 engine or something along those lines. And it's different because every time you do that, it's an exception to the regulations as they stand currently. And so when there's an exception there, Environment Canada has a separate set of requirements that they want you to follow. And that's where a lot of that historical data and declaration of intent comes in. So you can go to the next slide, Alex, get an example of that a little bit. Yeah, so on this is an example of a declaration, also called a compliance, a letter of compliance that we send to Environment Canada. So this is actually from a customer, though I've taken the customer's info off here. And so we can go through it a little bit. So of course, you always need the customer name. Down below where you can't see, they would have signed it. They would have had a representative sign it with their position, their address, their contact info, all that sort of stuff, acknowledging that that they've seen and understand everything that's in this. You have the date, and then right in the heart of the email, right in the heart of the declaration, I should say, we actually identify the paragraph of the regulations that we are addressing this to. So it's very clear to Environment Canada why we're sending them what we're sending them. We go down and we also highlight the application. So Dan mentioned this in his presentation, which is mobile versus stationary or standby. Those are the two big ones. So we tell them exactly what we're sending them. So in this case, it was a mobile compression ignition replacement. Yeah, and then we get into the meat and potatoes about the new engine versus the old engine. The manufacturer, the model, the full serial number, application, power, all that sort of stuff. So it's nice and clear for Environment Canada when they're looking at one engine versus the other. And then further down, we just note at the bottom where we spell out that we know how much time we're allowed to have to replace certain engines based on their application. So for stationary, we have up to 15 years so you can replace. And then for mobile, you can replace an engine if it's 40 years old, if it's the same engine that came from the original manufacturer. And so then in addition to this, we also send pictures. So we send pictures of the engine plate, of the machine plate, and then even the emissions label, which sometimes gets, unreadable depending on the application, but we send that too. And that's all in an effort to be really transparent with Environment Canada that we're doing our due diligence. And we found that kind of a package together with them, we get very positive responses from them. And that's a lot of the stuff that they're looking to see when you're importing engines into the country. Next slide, please, Alex.
Thank you very much, Jim. And for our final question, what does the future look like in terms of emission standards in Canada and as well globally? Sam. Sorry, I think you're on mute.
I am. Sorry about that. I apologize. Thank you, Alex. Emissions currently in Canada is Tier 4 final. Historically, Canada or Environment Canada really follows the EPA when it comes to North American emission standards. So the EPA or the US goes to Tier 4 final, and Environment Canada will typically mirror that and follow along. That has been the case historically. Now, you take places like California has their own standard. They almost march to their own drum beat, so to speak. That's even more strict than what Tier 4 final is, and very specific language, and also could be dependent on the size of the engine and the application as well, right? So we always advise our OEMs, if they are shipping into places like California, to go on the CARB website and have a look to see what the different nuances are that CARB might have that Tier 4 final or Environment Canada may not at EC or EPA. So that's historically what has happened. Stage 5. So go in the next slide, please, Alex. Sure. So stage 5 is already in Europe. And likely in the future, nobody knows exactly. Again, lots of things on the news we see today, and not to get political, but lots of different, lots of different chatter about possibly even changing what the EPA has put forward in the US. Will that change the landscape in Canada or change Environment Canada's response to that? I don't know. But as far as stage 5, it is in Europe. And when I alluding to my first part of the presentation, I had mentioned that Caterpillar made a conscious decision when they went to Tier 4 final, knowing that stage 5 was around the corner, knowing that they're a global company and they'd have to go into Europe, and that stage 5 would be DPF forcing. They incorporated DPFs in their engines very earlier on. So there you'll see a footprint. There's a Tier 3 engine, and if you look at the footprint on all 3 of those engines, it's relatively the same. So the footprint really hasn't changed that much. On the contrary, in some cases, it's gotten smaller, because if you had a 200 horsepower C7 in Tier 3, and now you're going to a 4.4 Tier 4 final, that footprint might actually be smaller. But the overall space claim, because of the after treatment, makes the entire package usually a little bit taller, depending on where you mount your after treatment, of course. So when you look at a Tier 4 final engine and you look at a stage 5 engine, in Caterpillar's, for example, they are identical from a space claim or a dimensional perspective. There might be some minor nuances here and there, but overall, from a dimensionally speaking, they are very, very similar. And also wanted to share with everyone online today that as of last year, Caterpillar, all the way from 55 kilowatt, or sorry, all the way from 19 kilowatt, all the way to 755 horsepower, is they are dual certified. So even though we don't need to be in stage 5 compliant here in Canada, those engines are dual certified and gives the ability to have, you know, a worldwide engine for higher emissions. Are we ever going to get away from Tier 3? Not in the near future, to be quite honest with you. There's lots of less regulated countries. Alex, I'll ask you to go to the next slide, please.
Sure.
Where I have my little handy map. So when we look at that map on what the world looks like today, you still have lots of Tier 2 or Tier 3, you know, less regulated countries, right? And whether it's just lack of regulations to move forward to a cleaner engine, which could be the case, but in a lot of cases, it's also fuel, right? You need ultra low sulfur diesel for these Tier 4 final engines to operate and if you don't have that fuel, it will create havoc on that engine and on that fuel system, more specific. So for an example, we have OEMs that sell globally. And an interesting kind of fun fact, you could have a Tier 4 final engine that accidentally ends up in a Tier 3 territory. You would have to actually de-tier that engine, and the local Caterpillar dealer can actually take that engine and de-tier it so it can use the local fuel and be able to operate as a lower emission standard engine. So lots of different regulations. I urge anybody that's shipping internationally to check the local standards and emission standards, and just to make sure you're compliant. But yeah, tier 3 engines are not going away anywhere in the near future, and Tier 4 final is here to stay, and nobody can really know what the future looks like as far as when is the next stage for emission standards in Canada or the US. It could be next month, it could be next year. There is no real clear path to that. And that concludes my section on emissions.
Thank you very much, Sam. Very informative, and Dan and Jim as well. Thank you both. We're going to open up the floor to questions now. We have about 13 minutes left here. Before anything else, Sharon G, do we have any questions selected here coming from email? And at the same time, we'll open up the chat.
Yes, Alex, thank you very much. We've got a couple of questions from our audience. The first one is, I'd like to replace an industrial engine, but the serial number is unreadable. How will that work with Environment Canada and the paperwork required for such a repower? So I guess that's for Jim.
That would be Jim.
Yeah, I can answer that, Sharon. So overall, Environment Canada always wants to see the serial number. It's the easiest way to go about, getting the replacement approved and getting the exception to those regulations. Worst case scenario, you can submit an exception to the exception, I suppose, to the rule. You can have you can submit to them a case and have them make a ruling on it. And it takes a little bit more work. It takes a little bit more detail, but it can happen for sure. Though they always have the last say, for sure. But it's something that we can definitely facilitate and that we've done before. So it's possible.
Thank you very much, Jim. Another question that has come through is, can you please better define what a remote location is?
I'll let Dan speak to that. You touched a little bit on remote applications.
Yeah, so to be honest with you, Environment Canada is intentionally quite vague when it comes to remote applications. All they define it as is no access to grid power, whether it's natural gas or utilities. They don't necessarily define it beyond that. They leave the due diligence to the manufacturer or OEM or the supply distributor, such as ourselves, to our OEMs on the line here, and the end user to make that determination on whether or not this location qualifies as a remote application. So it is intentionally, left a little bit vague to make that determination, but all they define it as is no access to utilities or grid power at the end of the day. Certainly you'd be hard pressed to probably justify something operating in the GTA as a remote location. But certainly, we have applications in Northern Ontario that very much qualify as remote locations. So it is definitely on a case-by-case basis, and that is something the team here can assist with to anybody in the audience. So I would encourage you to reach out to any of us on the line here, and we can better assist.
Thank you.
Another question has come through. California seems to be the leading edge in emission changes. What do we foresee as coming next in California, and potentially what would be the implications on the rest of Canada?
This will be timely for Sam.
Yes, I could answer that. It really is very difficult to know where we're moving forward. As you've heard in the news just in the last 2 weeks, it appears that the current administration in the US is looking at actually, I believe there was 31 different things with the EPA. I quickly looked on there. I did not see any industrial engines affected. And they're actually looking at going backwards on some of that. Now, having said that, there's been so much emphasis and investment globally in emissions, and more so here in Canada and in North America from OEMs and from a manufacturing standpoint. We are all moving in the same direction of getting closer to that net zero. Do I see it reverting back to tier 3? My own personal opinion is not, but again, that's just my opinion. And as far as current technology and emissions is concerned, when you think about an engine operating today in any city, and it doesn't even have to be a high densely populated area, that air going into that engine, that air coming out of the exhaust stack of that engine is cleaner than the air that's going into the intake. So you think about that. Every industrial engine out there with tier 4 final technology is almost acting like a little scrubber that's working out there in the field and actually cleaning the air, so to speak. And to Dan's slide, when you look at where we've come through the different tiers of emissions and where we are today, that's quite remarkable. So again, I know it's not. I know it's not a very definite answer as far as where CARB is going or where Environment Canada is going and when that change will happen. CARB, again, that's why I advise anybody that's shipping into look at the actual CARB website for specific with California, because they are in North America by far. They are the leader in that just regulations and what that cleaner available option is there on emissions. Definitely by far the strictest in them. So I hope that answers the question, Surinjit.
Yes, thank you very much, Sam. There's some questions about the fuel. What is different in fuel that is used in some lower tier countries?
So it's really the sulfur in the fuel, and that is not going to change anytime soon. In some countries, you need to have ultra low sulfur fuel for a tier 4 final engine to function. And if not very earlier on, many years ago, and we knew it. It's not when it's not if it's going to happen, it's when, right? Somebody buys a piece of equipment, somehow it ends up in a less regulated country. And it will create, you can clog up or foul up a fuel system in less than 2 weeks if it's in a territory where the fuel is not appropriate for that engine. So key critical to make sure you're not only meeting local emissions, but even in a less regulated country, to know what the fuel going into that piece of equipment is.
Thank you very much, Sam. There's a question about genuine filters. I know that they are best. It is best to use genuine filters to remove the engine oil contaminants. But what does it have to do with the after treatment system?
Jim, would you like to speak to that?
Yeah, well, it kind of goes back to that connection between the oil there, right? So it's everything that goes in the engine is it has a role to play there, and then the filter is going to it's going to ensure that you get more life out of the after treatment. It by taking out more of the particulates, it just it helps clean it out, and it does a lot of good work for that after treatment. And because like at the end of the day, the engine and the after treatment, a lot of the failures come from those contaminants getting in there. So anything you can do to prevent any of those contaminants getting in is gonna help it in the long run. Probably not the best answer. I could probably follow up on that maybe later with the individual who asked that in a more detailed manner. But yeah.
I'd like to add one thing, if I could, Jim.
Yeah.
Because I feel like I've grown up in the parts and service business and the tractor side of the business. So I spent a fair bit of time looking at filters, and quite frankly, looking at filters taken apart. So if you take it, and I advise, if anybody ever has the opportunity to take apart a cat filter and take apart a competitive filter and look at it side by side, it really does tell a story. And sometimes even just by feeling one with the other, like there's a significant difference in weight, but don't let weight be that factor. Cut a cat filter open and cut any competitive filter and look at the media. Look at the roving that keeps that filter media together. Look at that center core in that oil filter, and just look at the detail and the construction. And again, this seems like a little bit of cat yellow injection. And I'm sorry, 29 years in the business, it kind of gives you a little bit of that. But nonetheless, it is a very notable difference with one of the other. Just the surface media alone, you see how much more material is filtering oil. It's very dramatic, right? And it's interesting when people talk about equipment and cost of ownership. It seems like filters is one of the things that they zero in on. Well, how much are you paying for filters? But quite frankly, when you look at an engine or you look at a piece of equipment and you look at what it costs you for proper oil and proper filters, the percentage is very, very low of the overall cost, right? In comparison, it's really minuscule. But yeah, just wanted to add to that, Jim.
Thanks, Sam.
Thank you both.
Thank you very much, Sam. Next question is, how can Toromont assist me with my selection of equipment, engine, and for my equipment from a design and installation perspective?
I'll send over to Dan. Not sure maybe the question's referring to a replacement engine or a new engine, but Dan, would you like to speak to that for a moment?
Yeah, sure. Sam and myself have been in the business for quite some time, and absolutely, we assist our OEMs on a daily basis here in terms of selecting the right engines for the application, but also advising and trying to navigate through this emissions landscape as well, and doing our best to give our OEMs guidance along those lines. So that's really in the initial phase, but over here, we also have 4 full-time A&I engineers, and really their intent is to help our OEMs develop the engine and integrate the engine into their machinery. And as this process continues, at the end, when the machine is finally complete, our A&I engineers will complete something called an applications and installation audit, and that's ultimately the checks and balances to make sure that engine is meets the requirements that Caterpillar and Perkins expect of that engine. So really from from concept all the way to prototyping and testing, that's something that the team here can assist the people on the line with. So encourage everybody to reach out should you have any questions along that line.
Perfect. Thank you very much, Dan. I know we're just down to under a minute here. Time for one more, Sharanjeet?
Yes, time for one more question, and actually, it's a great question here. Obviously, we've spoken about the fact that there is a space claim for the units as we go into the higher tiers is much more larger. How is this managed to make sure that there is optimum space requirements, and what can Toromont do to assist with maintaining that? Because power density is premium, and along with the space requirements, that just makes the equipment so large. So how do we manage that?
Sam, you want to share some bit on that as far as space claim on the afternoon?
Yeah, that's an interesting question, and it's a great question. And I'll tell you, it's more of a challenge, especially with mobile equipment, right? So when you look at a piece of mobile equipment, many considerations. It's not just fitting the engine. You have engine hood and sight lines and so on. Those are all things you need to consider. And as you looked at my diagrams there, difference between tier 3 and tier 4 final, there is a significant height, especially if it's top mounted DPF. Now, having said that, there is lots and lots of options. When you look at how many options you have for an after treatment today through Caterpillar on any size, especially, sorry, I shouldn't say on any size engines, but anything 55 kilowatt, which is, 55 kilowatts, 75 horsepower and over. When you look at the options you have for after treatment, as far as where to mount it, where the outlets are rotatable, right? Because some manufacturers will make an after treatment, but it's welded on. So you are forced, if that outlet is facing 12 o'clock as top dead center going out, that's it. You're stuck with that. When you look at the options on the after treatment, there's lots of different options for where to mount them, what orientation, right? Whether it's vertical or horizontal, there's lots of options for that. Remote mounted or engine mounted. Lots of options for even something as simple as a def tank. Because let's be honest, you have a mobile piece of equipment, that def tank needs to live somewhere. And something as different as offering a horizontal or a landscape, a portrait or a landscape design tank that's the same capacity can make a difference. Different lengths of line, different orientation of line. So we really do have a very wide range of options, and work closely with our OEMs that they can fit that piece of equipment, whether it's offering CAD drawings or offering different options and going back and forth and having that discussion. Also, having said that, the one plus that we have noticed that I mentioned before is this is a great time to also look at timing and, it's a great time to look at sizing and say, do I really need that horsepower? So there's been a little bit of a shift in the industry as well. And because these engines require the load and require the heat, like Jim had mentioned, as far as letting the engine run and reaching temperature and so on. So now's the time where you say, do I really need 150 horsepower, or can I get away with 134, right? Because if I can get away with 134, you can almost go down a size depending on, right? You can go from a 4.4 to a 3.6. Well, that footprint now, or that overall engine size, has changed and puts you in a little bit of a tighter package. So lots of different options, and we're here to work with our OEMs and help in that stage, and have some great resources behind the scenes from an engineering standpoint to help as well with that.
Excellent. Thank you very much, Dan. And we'll wrap it up there. If there are any additional questions, we will reach out to you directly to answer. Once again, wanted to thank you all for joining us today. Really appreciate the engagement and your presence, and a special thank you as well to our panelists, Sam, Dan, and Jim. Hope you all have a great rest of your day.
Thanks, everybody.
Thank you, everyone.
Take
Good
care.
day.
Bye-bye.